Okay, this is Physics Lab 3 by Alejandro Molina. The purpose of this lab was to calculate the mass of a star and to calculate the required velocity to achieve exit velocity of the planet black hole system. The applied concepts that we used are the gravitational force concept, momentum principle, Newton's second law. The models we have are the black hole star model and the black hole planet ship model. The results were that the mass of the black hole was 8.6242 times 10 to the 43rd kilograms, and the exit velocity was negative 3 times 10 to the 7th and 2 times 10 to the 7th meters per second. So the fundamental physics concepts. Gravitational force is equal to negative the gravitational constant times our mass 1 and mass 2 divided by our magnitude of distance between the two squared times r hat. Our gravity constant is 6.7 times 10 to the negative 11th. Our momentum principle states that our momentum is equal to mass times velocity. The derivative of momentum with respect to time is our f net, and our perpendicular and parallel momentum with respect to time is equal to our f net. So Newton's second law gives us our velocity and position update formula, which you can see here. Model 1, this system was the star and our surrounding was our black hole. The initial conditions were that the star had initial velocity v naught and the black hole exerted a force of Fg on the star, and the star exerted the same force of Fg on the black hole. In Model 2, we see that the system is the ship, and that pink line in the surrounding is the black hole and the planet. The initial conditions were that the planet still had that initial velocity of v0. Our black hole exerted a force of Fg on the ship, and the star exerted a force of Fg on the ship. So this is the first model, the star black hole system. And you can see the parallel and perpendicular forces depicted in those two arrows. So this is the code for the first one, or for the model you just saw, and you can see in between lines 154 and 200 are calculations. The mass of the black hole was determined by getting all the masses recorded at each time interval and dividing them by the count, which averaged them out and gave us our massive black hole. This is Model 2. As you can see, that was the ship escaping from the black hole planet system. This is the code for Model 2. You can see between line 71 to 124 our calculations, and we determined through trial and error for line 61, 62 our speed of ship in the x and y direction. So what does it mean? What does it mean? The difference between net force and momentum. Momentum is mass times velocity, and force is mass times acceleration. Momentum is based off of force because velocity is based off acceleration. But other than that, the only difference is momentum is mass times velocity and force is mass times acceleration. And what if we wanted to put the ship in orbit of the black hole? Well, they must have the same force or the same velocity in the x direction, but a different velocity in the y direction, so that it wouldn't escape the black hole.